So hello everyone, I welcome you all in this lecture. So in this lecture we are going to implement the heating hold control like we did in the altitude hold case. So in theory also I have explained to you what kind of similarity is there between these two loops, how can it actually connect from altitude to heating loop, okay, and same we are going to do here, okay. So this is a window you are very much familiar, so many times I explained to you, okay. So in a aircraft roll control design lecture you can go, you can have a feel for all the parameters I will explain, okay. So why we need this, because we have to run this file and we have to save in the workspace, and this we will utilize in a Simulink, okay. All the variable, right, same condition, derivatives value, okay, etc. Okay, so that is a good way to do this, okay. Unnecessary changing the everything in a Simulink one by one, it will be little hectic, okay. Already familiar with the root locus, you guys, right, okay. Go back to my aircraft roll control design class, you will understand. Now we are interested in this, okay. So now in theory I have explained to you how you will control the heading of a aircraft, okay. Now in this case we are going to implement in the Simulink. So let us consider when we take a roll, and if you are not taking care of heading, what will happen? For example, let's say this is a 5-degree roll I have given. So what is expected? What is positive? This is positive roll, right? So it should produce some kind of, start the heading from 0 to some value, right? 30, 40, 50 degree plus, okay. Let's run this. Okay, this is G by V, right? G by V, already explained to you, right? Now when you run this, what is the expected result? It is taking a roll and moving like this. But this is not the controlled heating response, sir. Although you can say it is a controlled roll response, but not the heating response, okay. 5-degree you are getting roll, but not the controlled heating response, okay. That is why the this plays the important role of a heating control, okay. How will you control the heating? For example, if I am taking a takeoff from any position and I want to go there, so what will happen? You have to take off and you have to take a turn and fly in that direction. So let's say that direction heading is 60-degree from the north, and you are flying towards the north, taking the takeoff from the north. So you have to go to the 60-degree from the north. So that is why the heading control is important. And let's say if you are taking the takeoff and you may take down complete 180-degree turn, and sometime it has happened that runway is not clear, so you have to loiter at a particular altitude. So continuously you have to change the ending from 0 to 360, 0 to 360, like that, okay. Okay, so that is this way the heading is important. So what I explained to you in the theory, okay. Let's connect this. This is the, what you can say, P by del A transfer function, P, okay, PS by del A S, right? And this will integrate, you will get what? Okay, and this G divided by V, when you will get and integrate, you will get psi, right? And here what is this? Delta A, and here P command, and here phi command, and here psi command. This is gain P for a heading loop. This is gain I for a heading loop. This is gain P for roll loop. This is gain I for roll loop, and this is the feedback gain for a rate loop. Not required. You can put 0 because already you have a well damped system. First order, only real part is there, right? Later on, when you include the dust roll mode in the plant and all everything, then you may require the gain. Okay, no problem. We'll do the later part. Okay. As of now, this is just the first order one. Okay. Now, so you can see everything is clear, right? Now, what is this? Why I'm using step block? So I'm taking as a, see, I want to check my heading complete. It's better to, if see, you can command 30 degree, you can command 40 degree heading angle, but it is better to take a complete sweep 360 degree. So I have taken started from 0 going to 360 degree and with some limitation. What is the limitation? 3 degree per second. Turning 3 degree per second. That is a standard rate for turning the commercial aircraft. Okay. When I say turning, that means side yard is a turn rate. Okay. Now, when you run this, you can see how I have commanded and how I am getting. Okay. For example, let's take a more time to run the simulation because it is the rate is 3 degree per second, right? So you can see how it is. By improving the gain and all, you can actually have a close match. Okay. 0.5. Let's see if I increase the gain. It's going to the closer to that. Okay, that is how by changing the gain you can improve the response. So basically it is good. Complete 360 degree you have sweep, and whatever you are commanding from the blue line, the yellow one is actually following. Yellow one is actual and blue one is commanded one. Okay, so how beautifully the aircraft is taking turn from complete 0 to 360. Okay. Are you interested to check the roll? What will be the roll angle? Finally, when there is a heading is attained, so finally the roll angle should go to 0, right? See, when taking turn, final heading achieves, bring back the aircraft to the level condition. So that is how the roll going towards the almost 14 degree and going bring back to the 0. Okay, that is how you can actually, because it's important to see the other variable also, how the roll angle is. See, at a one time when you see complete roll rate, roll angle, heading angle, then you will have a better understanding of a control loops. I am not telling in this case only. If you are learning the altitude hold control, you should see Q, theta, H at the same time. Okay. And how G by V I am getting to understand, right? L sin phi is mv square by r, and L cos phi is W during the band. Okay. So divide this two, you will have a tan phi equal to V square by R into G. Put W equal to mg, so mm will get cancelled. Okay. So this is a small angle, tan phi become phi, and V by R you can write psi dot, and this will be what? 1V by G. So you can write G phi by V as a psi dot. That is why G 9.81 by V I am multiplying by phi, and then this is psi dot integrating, and then I am getting finally psi. Okay. Remember this psi dot, it's not in the I mean to say body frame, refer to the inertial frame. So that is why in V you have to take Vg, not Va, not relative airspeed if there is a wind. Okay, I hope this clear to you, because this is an inertial frame. Okay, so we have to deal with the ground velocity, not the relative airspeed. Okay, all right. So if you have any question related to anything, any gain, any block, any transfer function, any feedback, please put in the comment section. I will be happy to answer. Might possible that when you ask some question, I will read, I will try to answer, and I will learn some things. Okay, so it is a other way you can also teach me. That is how we generally learn together, right? We'll meet in the next class. Thank you so much.